So I thought it might be helpful to see one more example of Descartes' rule of signs. And it says to determine the maximum possible number of positive and negative real zeros. So you don't have to do the 2 or 0, just 2 would be the maximum, if that's what it turns out to be. Okay, so max number of positive real. Okay, so we count sign changes. Positive to negative, that's one. Negative to positive, that's one. Positive to negative, that's one. And negative to positive, that's one. So it looks like 1, 2, 3, 4 sign changes, and maximum number of positive real zeros is 4. Okay, and if you were counting down, it'd be 2 and 0, but we're just doing maximum. Okay, now we're going to do the maximum number of negative real zeros. Okay, so we find f of negative x, which is going to be 2x to the 4th. That one won't change. This one's going to change because it has an odd exponent. You can write this all out by putting in the negative x. This one's not going to change. This one's going to change. And this one's just 12, so it's not going to change. Okay, now I feel guilty about doing it that way, so let me write it up above here. If I put in the negative x so you can see what's happening. Okay, so this one's not going to change. It stays 2x to the 4th. But this one is going to wind up being a negative x cubed times the negative, so it becomes positive 10x cubed. This one, when you square a negative, it's going to be positive, so it's not going to change. But this one, you've got a negative 15 times negative x, that's going to change to positive. And then finally, the 12 isn't going to change. It looks like I'm positive, 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 no sign changes. So 0 negative real zeros. So you wouldn't even try the negative numbers. Like if you were trying to find, P over Q and you were going to try to find the zeros, you wouldn't try any of the negative cases because, you can't have any negative real zeros. Okay.